when you see them for the first time on the test, right? Let's figure all this stuff out. By the way, physics is a class that makes you feel like not smart. Okay. So if you're like, I don't know how to do this, that's the first part of the process. Okay. That's how I felt when I learned it. So don't be too stressed. You got to just like take the approach of like, well, I just need to figure this stuff out. So anyways, problem number 3, it says we have a 50 Newton box at rest. So now remember, when they say 50 Newton box, they're talking about that's the weight of the box, which is mg. And if we think of it in terms of force, there's usually a negative associated with it. Well, we don't know yet. It might be at an angle. I don't know. But anyways, the coefficient for static friction on the box on the surface is 0.50. And then the one for kinetic friction is 0.30. The horizontal 20 Newton force is exerted on the box. The magnitude and acceleration of the box is mostly near. All right, so let's draw the picture. Okay. So I've got, oh, we're going to get fancy, you guys. No, it's not that fancy. Here we go. Whew. Good thing I took all that time writing that down. So I got my box, right? It doesn't give us any angles or anything like that, so we're assuming that the box is on a level ground. It says that the weight of it is 50 newtons, right? Okay. And it says that there is a force that's being exerted, and we'll make this positive and we'll make this negative. The force is 20 newtons. So the real question is, there's friction here. It says it's starting at rest, and they give us 2 coefficients. So they give us the coefficient for static friction, which is 0.50, and then they give us the coefficient for kinetic friction, which is 0.3, right? And I should also point out that usually static friction is bigger than the kinetic, okay? So this represents some sort of frictional force. And remember, frictional force is mu times the normal force. So what's the normal force? Well, because this is a level surface, it should be 50 newtons. So we can calculate the amount of force required to move the box. We need to figure out the static friction force. So how do I do that? Well, the static friction force will be the coefficient of the static friction times the normal force, which would be 0.5 times the normal force, which is funny. This is the normal force. Don't get all the n's confused. Times 50 newtons. So in order to get this thing moving, you'd have to pull with at least 25 newtons. Oh, this is in the negative direction, so it's negative. So what is our net force? Well, our net force, if we sum up all the forces in the x direction, is going to be negative 25 plus 20. We're not actually moving because this is our maximum frictional force. In other words, it's not pulling on it. That's the force that we have to overcome. So the velocity then would be what? What I'm saying is that this force here would have to be greater than 25 in order to pull it. Let me write that in a different way because somebody not... Yeah. So in order to move this box, I'd have to pull with a force greater than 25. So the velocity then is most likely 0 meters per second. Okay. Oh, did they say velocity or acceleration? The acceleration. So we just change that a little bit. Acceleration would be 0 as well because it's not moving. And somebody will look at this and they'll add these up and they'll go, oh, it's -5 and do a bunch of math. No, you got to use your brains a little bit, okay? Because you can pull on this up to 25, but there won't be any motion until you go above 25 newtons. That's what static frictional force is. The frictional force is going to hold it in place. If I pull with 20 newtons here, the frictional force will be 20 newtons here, right? But what's the max? That's why I should say this is the max. I did say it over here, okay? So that thing won't move until I pull at least, well, a little bit more than 25 newtons, okay? That's problem number 3. Any questions on that one?